Alright, so this is the individual mastery checkpoint, number 5. And so first, we are doing the integral of z minus 5 times e to the z dz. So the formula right here is for the integration of by parts is the integral u dv equals u times v minus the integral of v du. So to correctly identify all of our u, du's, and v's, our u is z minus 5, and our du is 1. Our du is e to the z, and our u is e to the z because of the exponential rule. So then we plug our values into, actually we do this part first. The integral of z minus 5 times e to the z equals z minus 5 times e to the z minus the integral of e to the z times 1. So because our du is 1. And then we simplify that to this. Z minus 5 times e to the z minus the integral of e to the z dz. Finally we have z minus 5 times e to the z minus e to the z plus c, or a constant, Mr. Sunshine. That would be the end for problem 1. So we are given this very large equation, which is the integral of negative 7x to the 6 minus 90x to the 5th plus 2x to the 4th plus 6x to the 3rd plus 60x squared plus 6x plus 60 over x to the 7th plus 10x to the 6th plus x to the 5th plus 10x to the 4th. Given that equals 2 over x plus 10 plus 6 over x over 4 minus 9x over x squared plus 1. So we do the fraction rule, is a plus or minus b over c equals a over c plus or minus b over c. So the first integral is 2 over x plus 10 dx, which equals 2 ln absolute value x plus 10 plus Mr. Sunshine. Then we have the second integral as the integral of 6 over x to the 4th dx equals negative 2 over x to the 3rd plus Mr. Sunshine. Then our third integral is the integral of 9x over x squared plus 1 equals 9 over 2 ln absolute value bar x squared plus 1 plus Mr. Sunshine. Then we add all these integrals up. It's 2 ln x plus 10 minus 2 over x to the 3rd plus 9 over 2 ln absolute value x squared plus 1 absolute value plus Mr. Sunshine. And if it focuses, we'll go into number 3. So for number 3, we have the integral. And so for this one, we're supposed to evaluate the integral using appendix A. So it's 1 over x squared times the square root of 16 minus 25x squared dx. So using appendix A, we evaluate it as k, because it's 1 du x squared u squared 16 a squared 25 x squared is u squared. And this equals, what we should have to plug in is negative square root a squared minus u squared over a squared u. So our u squared is 25x squared. Our u is 5x because that's squared. Our a squared is 16 and our a is 4. So then we plug all this stuff in and we get negative square root 16 minus 25x squared over 16 times 5x plus a smiley face of me. I'm a bad drawer, but going into number 4. So I think I actually skipped a page. Going to number 4, we have the integral of 0 to 3 h of x dx. So our x is 0, 0.5, 1, 1.5, 2, 2.53, and our h of x is 10 times 10, 30, 60, 100, 140, 210, 280. So our M3, we do 1 times 30 plus 100, because it's the middle of these two, plus 210 equals 340. And then after that, The M3 from calculator is also 340. So the midpoint is an overestimate because the graph itself is concave down. So our B is, so this is for the trapezoidal rule, yes. So it's 3 minus 0 over 6 times 3 over 6 is 1/2 equals our delta x. Yeah, this is trapezoidal. And then the T6 equals, so I crossed this out, I just remembered. But I actually did, so this is the actual formula for the trapezoidal. Yeah. So we have f of 0 plus f of 0.5 over 2 times 0.5 plus f of 0.5 plus f of 1 over 2. And this is a equals 1/2 times b1 plus b2 times 0.5, f of 1. This is all from right here. Like this f of 1, f 1.5. So we have f of 1 plus f of 1.5 over 2 times 0.5, f of 1.5 plus f times 2 over 2 times 0.5, f of 2 plus f of 2.5 over 2 times 0.5 plus f of 2.5 plus f of 3 over 2 times 0.5. That's the delta x. Then 10 plus 30 over 2 times 0.5 plus 30 plus 60 over 2 times 0.5 plus 60 plus 100. So this part right here, this is just plugging in what f of 2 is, or what f of 2.5 is, or f of 3 and f of, so this is just plugging all those values in, because if we go to f of 0, we get 10. We go to f of 0.5, we get 30, and that goes all the way along there. And then it's 347.5, and then this is an overestimate. Yeah, this is an overestimate because it's concave down, and no, sorry, underestimate because it's concave down. Sorry, my handwriting. I forgot what it was. So then D, we got Simpson's rule. So the equation is S of 6 subintervals, change in x over 3, then brackets f of x of 0 plus 4 times f of x of 1 plus 2 times f of x of 2 plus 4 times f of x of 3 plus 2 times f of x plus 4 plus 4 times f of x plus 5 plus 5 times f of x. Then our delta x equals 3 minus 0 over 6 is 1/2. And then we do 1/2 over 6 is 0.166x. So we do this, brackets times 30, plus 4 times 60, plus 2 times 100. This is all from up there. Plus 2 times 100, plus, sorry, I exited that out, actually, because I did it wrong. I just remembered. So it's 1/2 over 3, brackets 10 plus 4 times 30 plus 2 times 60 plus 4 times 100 plus 2 times 150 plus 4 times 210 plus 280, all times 0.166, and that equals 343.62. So the Simpson's rule uses parabolas instead of rectangles or trapezoids, which gives us an overall better approximation. And I just remember something. If this is the most accurate, and this would actually be under, and that would be over. So this is actually the overestimate. This is the underestimate. If this one's most accurate. So I just corrected that myself. And so the integration by parts for the bonus, I said we could pull out 5 from the integral to the outside, and then we can have our u be x squared. I didn't really know how to evaluate it fully, so I just did that part of it. Thank you.